Okay. So we're going to go ahead and we're going to go through this real quick. So there's a couple of different types of databases that I need to make you aware of. When we deal with CSV files, and you hear somebody say, oh, well, it's a flat file, that's the CSV, all right, or that text file. We refer to that as a flat file way of storing data. People used to refer to it as a flat file database. It's not really a database, right? There's no dimension to it, all right? We're not able to create relationships between things, all right? It's a very quick, dirty way for us to be able to store and retrieve data. It comes in very handy. You should be using it. I am not discouraging you from using it. I just want you to understand that it's not a database. It's just a way of storing some stuff. Then we have single users. And the one you're most familiar with for that is Access, Microsoft Access. It's a single user database, meaning that it's designed for one person to be able to inputting and retrieving information from it. If you're like, well, nobody uses Access, no, you're wrong. Why do you think Microsoft spends millions of dollars a year revitalizing and revamping Access? It's because it's heavily used by smaller shops, small mom and pop shops, and business individuals all the time to have access to a private database right there. So that's going to be a single-use database. All right? So then we're going to get into the multi-use and the large use. That's going to be like MySQL. So SQL, okay, that's good, Adam. So SQL stands for Structured Query Language. So when I see your resumes in 489 in a couple semesters, and you have languages listed, and I don't see SQL, I'm going to be like, where's SQL? Right? SQL stands for Structured Query Language. All databases use SQL. MySQL is a specific database that's geared towards, well, it was geared towards medium-sized businesses. This is what happened. There's a reason that MySQL and PHP became so popular. It's because of this little website called Facebook. You guys ever heard of Facebook? Tiny website, right? When Zuckerberg created that, he used what was freely available, which was the LAMP stack, which had MySQL and PHP in it. Problem was, it wasn't suited to be able to handle 2.5 billion users. But he painted himself into this corner. He didn't want to pay Oracle exorbitant amounts of money. So he actively started developing, well, he didn't, Facebook did, MySQL and PHP. So they are out there actively developing. They're some of the biggest contributors to these two technologies on the planet because their whole infrastructure is built around it. So originally it was MySQL for medium size. I'm talking a couple thousand people. And now it can support upwards of a couple billion people because of Facebook. Other ones we have out there, Oracle and MS SQL. You'll hear people say SQL Server. You'll have people say MS SQL. Same thing for MySQL. You'll hear people like me, I say MySQL. That's just what I grew up with. And you'll have other people say MySQL. There's no difference. However, they are all what we refer to as relational databases. Okay? They're relational databases. What a relational database is our data begins to take on form. It begins to take on shape. And we're capable of storing data into our database, it being a high level of resilience, meaning we're not going to have a lot of duplication, with high availability. That means that when I make a request, I get that answer very quick. A flat file that contains 200,000 entries, it's going to take a while for a computer to search through 200,000 entries, or 200 million, or 200 billion entries. In comes a relational database. High availability, highly redundant, high integrity. Integrity. When we accept the data into our database, we make sure that it is clean, and we make sure that it is validated. So now this ties back to me talking about regular expressions. When you program these things, making sure that your users don't make errors. The sooner you realize that you are a human being and you make mistakes, and that everybody else that uses your system is a human being and they're going to make mistakes, the cleaner your code is going to be and the better your stuff is going to be. So what are the relationships? There's 3 of them. There's one-to-one. There's one-to-many. And then there's many-to-many. All right. I will show you on Friday all of these, how they're actually created within a database. They're created with one or more tables. But in a one-to-one relationship, one object has a relationship with only one other object. And that one and only other object only has one relationship back. I'll give you an example to get us started. As a person that resides in the United States, doesn't matter if you're a U.S. citizen, if you reside in the United States and you make money in the United States, you must have what? It's your most guarded number on the planet. Social Security number, right? That is a one-to-one relationship. One individual has one Social Security number. You cannot get a different Social Security number. After you die, contrary to what people think, that number will never be reused. There's 10 billion of them, so I think we're pretty safe for now. There are ways before we exhaust those. But there's an integrity issue of why we do not duplicate Social Security numbers. After you die, if somebody needs to look up your information, they need your Social Security number, and if it's attached to somebody else, we're not getting the right data, right? Now, are phone numbers one-to-one? No. They are not. They are not. What's another example of a one-to-one relationship that you have with something else? That's the easiest way to think about it. Blood type. One person has one blood type. It depends on how you set that up, Ryan, because I can't remember what the blood type is. Somebody knows it, but there's one blood type that's universal. And if you have, is it O negative? And if you have it, they want it, because everybody can accept your blood type. Not morbid at all, by the way. Because somebody else, phone numbers are logical, so if you give up your phone number, somebody else can get it. So it's not one-to-one. Credit card numbers, right, so this is a good example, all right? This depends on how you as the database administrator set up the relationship. If you say, I'm going to have one person to one credit card number, fine, it is. But if there's ever an instance where there's 2 people that can share that credit card number, then it's not. All right? So as I talk about this, you need to remember this is highly dependent on you and your choices and what you set up when you model it. Joshua. A VIN number for a car is an exceptional one, right? That's the vehicle identification number. It's a unique number for every single car that rolls off of the plant. And by the way, we could do it for serial numbers too, right? So you kind of get the hang of that. MAC address, physical address, right? Every device on the planet supposedly has one unique number. We could spoof it, that's another story, right? All right, what about a one-to-many? What's an example of a relationship that you have that is one to many? One to many. Example of one to many. It could be if you define it. Ahmad said phone number. It could be if you define it that way. What's another good example of one to many? Wi-Fi? How many access points have you seen in this building? Aren't you the one that scanned the network earlier and like, oh my God, look at all these devices? How many people are uploading stuff to the server up there? Many people. There is one server. In that case, that would be acceptable. You are in control. I could come up with other situations where it's not a one-to-many. Okay? You need to remember this. You are in control. However you set it up, that policy is in place for that database. All right, here's the example that I kept alluding to that nobody got. One professor in a class has many students. I did keep pointing to myself and to you. All right. What about a many-to-many? Okay, let's stay in the physical realm. It's easier for us to wrap our head around that. All right? An instance where there's many of you relating to many of something else. Many students are in many classes. That's a many-to-many relationship. Now, is there a time where it's one student's only in one class? Sure. But the vast majority of the time, it's many students are in many classes, so as a database administrator, you would want to set it up that way, right? What's another example of a many-to-many relationship? How about there are many cars that park in many parking spots at a mall? Many-to-many relationship. Okay? There are, now I'll bring in a computer one for you, right? There are many IP addresses for many computers or many nodes on a network device or a network in general. All right? So on Friday, don't leave yet. I got 5 minutes. He's not in the class, so he's allowed to leave. On Friday, I'm going to start giving you the hierarchy of a database, and then we're going to start working with MySQL Workbench. So the book, you can start playing with this on your own if you want, but the book for Chapter 7 has you using a command prompt. It can be frustrating and time-consuming to be using a command prompt. And trust me, you'll get enough experience with a command prompt on your own. All right? So we're going to use a product called MySQL Workbench, and I want to get everybody logged into MySQL Workbench real quick. So, on your computers, and I want to walk through everything real quick as well. So on your computers, find MySQL Workbench. So you click on the search and type in and then it's going to be MySQL Workbench. It's going to be that first hit. You can download this software for free onto your Windows, Linux, or Apple machine. All right? MySQL Workbench. Yes, sir. What's that? Yeah, it's on Mac. Yeah, you can get it for Mac. Did I not say Mac? Did I say Windows twice? I thought I said Mac. It'll still be available. Yep. They'll have a port over. They're working on emulators for that, and I will probably abandon Macs if they go full ARM. It'll be difficult for me to do. I don't think that it is. I'll abandon it because I think ARMs are great and they have a place, but I don't think they're ready for desktop yet. All right. So MySQL Workbench is a professional tool that gives us a variety of resources to do different things. For example, we can model databases in here. But the thing we're going to use it for is to be able to create MySQL scripts and to execute those scripts. So what we need to do is right here where it says MySQL connection, you're going to click on plus. All right? Now I want to walk through this. I want to explain this to you. So you want to take notes, or you want to think about it. I'll make the video available to everybody. But you want to, as we walk through it, you want to think about it. So here in the connection name, you're going to put in, iTech 315 server. Where it says connection method, I want to take a minute and I want to tell you that we are sending, the way we're going to do things, it's going to be a standard TCP/IP. What this means is all of the modifications that we make on our database are going to be sent across our network in clear text. Does that sound like a good thing? It's because it's not in a production environment. We're going to do it because I want to take out the complexity of setting up PuTTY and all the other things that are associated with setting up SSH. All right? I didn't want to burden you with that, so we're not doing it. In a production environment, you're going to want to do standard TCP/IP over SSH. We're going to do standard TCP/IP. What's your host name? Yep, itech315.frostburg.edu. Port is going to stay the same, 3306. What's your username? Yep, whatever your username is for your email address, just the username. And then what you want to do after that, whoops. Yeah, you do need a password. Then what you want to do after that is you want to click on Store in Vault. All right, so it remembers your password, so you don't have to click it every time. You want to open that up. Don't put your password in. What is your password? I see some people doing it. What's your password? Student ID number. Don't put that password in for the school. I don't know what that is, right? I know what your student ID number is. So you put that in, and then you click OK, and then you're going to click on Test Connection. And it should come back and should say, Successfully made MySQL connection. It might ask you for your password again, so you might have to type in that number again. Does it say successfully connected? No? Did you put your username in right? You got a 0 on the end of it? Try putting your password again. Remember, it's that number. Anybody else did not work? Everybody else is good? So this is what you need to do. You want to go home tonight. You want to download MySQL Workbench. You want to get the test connection set up so that when you come in and you have questions for me, I can address them for you. Yes? So click on Test Connection. Test Connection. Right? Test Connection after you've done that. Send me an email real quick. I'll look at it in a few minutes. Good? Oh, I have one problem that had it. One person had a hiccup. All right, that's it. I'm done. You can start looking at stuff if you want, okay, in the book. But I really want you to just get the MySQL Workbench set up, and then we're going to start walking through some stuff in class together. Most people really dig these last 2 chapters. All right? All right. We'll see you soon. Yep. Is yours not working? No, not that. Oh. Okay. What's up? Okay, parse error, syntax error, unexpected else. On what line? What's it say? Okay. You forgot a semicolon. I don't know where. Forgot a semicolon. Where do you think you forgot a semicolon?